In this video, we will introduce terminology that will be used throughout the series. Of note, multiple different knot-tying lexicons have been proposed in the surgical literature, so the terms and definitions offered here are not universal. We will first define terms related to the anatomy of a knot. Shown here are 3 stages of a knot being tied. On the left, the black suture strand has been passed around the cardboard cylinder. In the center, the suture has been tied around the cardboard cylinder, and on the right, the suture ends have been cut short. We will define the suture strands as the 2 ends of the suture that emerge either from the knot, as in the center image, or from the structure that the suture has been passed around, as in the image on the left. We will define the knot as the site where the 2 suture strands have been fastened together by tying. After the knot has been tied, we define the loop as the length of the suture that surrounds the structure or structures being tied. And when the suture strands are cut short, we then refer to them as the tails of the knot. We will next define several terms related to the qualities of a knot. The first category of qualities relate to what we will refer to as the tautness of the loop. Shown here are knots that have been tied around cardboard cylinders with 3 different levels of loop tautness. The knot on the left is an example of what we will refer to as a non-apposing knot, known colloquially as an air knot. In a non-apposing knot, the loop, highlighted in blue, does not appose the structure or structures that it is being tied to. This results in the loop incorporating air, highlighted in red, instead of being apposed to the structure throughout its length. The knot in the center is an example of what we will refer to as an apposing knot. Here the loop, again highlighted in blue, is in contact with the structure that it is being tied to throughout its length. The loop is neither looser nor tauter than the structure that it surrounds. The knot on the right is an example of what we will refer to as a strangulating knot. Here the loop, again highlighted in blue, is so taut that it has narrowed the lumen of the cardboard cylinder, and a portion of the wall of the cardboard cylinder has been contorted outside the perimeter of the loop to accommodate its tautness. Importantly, each of these types of knots are useful in different scenarios. For example, the non-apposing knot might be used when creating a drain stitch. An apposing knot might be used when closing an enterotomy, and a strangulating knot might be used when ligating an artery. The other important category of qualities is that of knot security. Knot security exists on a continuous spectrum, but we will loosely refer to insecure knots as those that will slip with relative ease. For example, here we finish tying a knot around a foam blue cylinder using shoelace. The knot is an apposing knot when we finish tying it, but if we then apply force to the knot, we can see it slip and quickly become a non-apposing knot. If we continue to apply this force, the knot will become completely undone. We demonstrate this concept here again with a different setup in which 2 brass rings are tied together with a suture. When we pull the 2 brass rings away from one another, we can see the knot slip from an apposing knot to a non-apposing knot, and then eventually become completely undone. The suture is still intact with no breaks. In contrast, we will refer to a secure knot as a knot that is relatively difficult to slip. For example, here we tie a non-apposing knot that is secure. We can attempt to tighten it further by pushing down on the knot from either side, but this is unsuccessful because it is a secure knot. It is important to note that the security of a knot and the loop tautness are completely independent. In other words, this knot is a non-apposing but secure knot, while the last knot was an apposing and insecure knot. A throw of any loop tautness can be either secure or insecure, with the result being dependent on how it was tied. Let's look at what happens to a secure knot when high forces are applied to it. Here again are two brass rings tied to one another, but this time a relatively secure knot configuration has been utilized. For orientation purposes, we label here the knot tails, the knot, and the loop of the knot, seen on the underside of the brass rings it is tying together. The brass rings withstand a much greater degree of force than in the previous demonstration, and while the knot initially slips, the rate of slippage slows, and then the knot breaks, in contrast to the insecure knot, which became undone without breaking. If we look at the broken knot closely, we can see the knot, the tails of the knot, and the loop of the knot, which has broken. While it is difficult to see, the loop broke right at its junction with the knot. This is classic for the location at which secure knots will break. Next, we will define throws and discuss different types of throws. We will define a throw as the act of wrapping one strand of suture around the other strand, and then passing the former strand through the resultant loop. Throws are the building blocks of knots. There are two types of throws that we will commonly use, the underhand throw and the overhand throw. A one-handed underhand throw is shown here. This is referred to by some as a karate chop throw. A one-handed overhand throw is shown here. This is referred to by some as a claw throw. Next, we will define the difference between identical and opposite throws. When two consecutive throws are performed, if they are both performed overhand or both performed underhand, they are referred to as identical throws. In contrast, if one of the throws is underhand and the other is overhand, regardless of the order, they are referred to as opposite throws. Shown here is the performance of two identical throws. An overhand throw is performed and tightened, and then a second overhand throw is performed and tightened. These two throws are identical. Shown here is the performance of two opposite throws. An overhand throw is performed and then tightened, and then an underhand throw is performed and tightened. These two throws are opposite. Next, we will describe how the method of tightening can produce two different types of throws. These are flat throws and half-hitch throws. Shown here is the performance of a flat throw. An overhand throw is performed and tightened in such a manner that equal and opposite forces are applied to the suture strands, with the direction of both of these forces being parallel to the surface of the wooden board, highlighted in green. This is in contrast to a half-hitch throw, in which one of the two suture strands is held tautly, in this case the black strand, by the left hand, and the other is pushed down to the wooden board, in this case the white strand, by the right hand. Note that the force applied to the black strand is roughly perpendicular to the surface of the wooden board. If we look closely, we can see that even though the same overhand throw was performed, the resulting throw configurations are markedly different. In the half-hitch throw, the black strand is roughly straight, and the white strand wraps around it, whereas in the flat throw, both strands wrap around one another and are roughly symmetric. While it is helpful for learning purposes to consider flat and half-hitch throws as a binary system, in reality there exists a spectrum of throw configurations, and the flat and half-hitch throws represent the ends of this spectrum. We demonstrate this concept here. We start with a flat throw, but then apply force only to the black strand held by the right hand, and gradually change the orientation of that force from one that is parallel to the surface of the wooden board to one that is perpendicular to it. As this maneuver is performed, a spectrum of knot configurations can be observed. Next, we will discuss terms that relate specifically to half-hitch throws. First, we will define the post and non-post strands. In the half-hitch throw shown here, the black strand exits the wooden board and then passes through the first throw as a straight line, like a post. This strand is then referred to as the post strand. In contrast, the white strand, which wraps around it, is called the non-post strand. Every throw can either be tightened on the same post as the previous throw or on a different post from the previous throw. A half-hitch knot with a single post results when two throws are tightened on the same post strand. For example, here an overhand throw is performed and tightened using the black strand held by the left hand as the post strand. Then an underhand throw is performed and the throw is tightened once again using the black strand held by the left hand. In contrast, a half-hitch knot with alternating posts results when two throws are tightened using different strands for the posts. For example, here an overhand throw is performed and tightened using the black strand held by the left hand as a post. Then an underhand throw is performed, but this second throw is tightened instead using the white strand held by the right hand as a post, with the left hand pushing the black strand down to the wooden board. If we take a closer look, we can see that for this second throw, the white strand, highlighted in blue, passes as a straight line or post through the throw, and the black strand, highlighted in red, wraps around it. Most knots comprise more than two throws, and so a half-hitch knot may have a mix of throws that are the same post as the previous throw or an alternate post from the previous throw.